So this is part 2 of our video of how to sketch various functions. We've already looked at the first expression, the first equation. So that was done in video part 1. Now we're on to the second one. Alright, so as we said before, these are the key features that we want to find if it's concave, convex, axes, intercepts. And it's all about what technique we use is how we're presented with the information. So with this one, straight away, we can see, okay, because it's a positive in front of the x squared, we know that this one is now going to be convex. To find my y-intercept, as we usually do, we make x equal 0. So that's a straight out negative 15. So we write it as a coordinate, let's be precise. And then to find our x-intercepts, we know that we're going to make y equal 0. This is just a constant process. We've already got everything on one side here. So we will look, we'll inspect, we'll say, let's give ourselves a couple of seconds to see if we could factorize it, because that's going to be the quickest and most efficient way to solve. And I hope you can see out there that clearly we have two values. That times together gives me 15, but has a difference of 2, and they would have to be 3 and 5. So going to see if they will work. 3 and 5. One's got to be positive and one's got to be negative, because we want to times together to give me minus 15. And when we add them together, we want negative 2. So it's got to be plus 3, take 5. So pretty quick here on our x-intercepts, we will have minus 3 and positive 5. Again, finish off, write them as coordinates. Okay, if you wanted to, you could have used the quad formula, you could have done completing the square. We'll look at another equation when we have to do completing the square, because you wouldn't be able to factorize it. Okay, now how do we find the vertex? We could just average out our x-intercepts. Okay, so the axis of symmetry, or the x value of the vertex, is we can just average out. As we just said, I'm repeating myself, sorry about that. We can average our x-intercept. So minus 3 plus 5 divided by 2, right, we get 1. If you wanted to, right, you could have used the good old formula that we are aware of, minus b over 2a. Okay, so just a reminder that this is our vertex formula. Okay, minus b over 2a, we've seen that, comes from our quadratic formula, and that's just fancy pants for saying sub your x value back into the equation to get your y value. All right, and we can see our b is minus 2, so minus 2 becomes 2. A is 1, so 2 times 1 is 2, and we're left with exactly the same situation that we have here. To get our vertex, our x value is 1, so we're going to substitute this back into our equation. So my y value will become, right, go back up here. X is now 1, so 1 squared is 1, minus 2 times 1 is 2. Take 15, and that gives me minus 16. So now we have all the information that we need to sketch our function. Okay, so we look at, we've got its convex, and we've got x-intercepts of 5 and minus 3. So we've got a little bit positive, more to the positive than the negative, and a y-intercept is downstairs. Right, so we've got a fair bit going underneath. So I'm going to go like this. Right, because we've got quite a few things that are negative, I want to leave a fair bit of room downstairs there. I might want to make that just a little bit longer. There we go. Okay, so we've got an x-intercept here of minus 3. Again, it's a sketch. I'm not doing this exactly to scale. And of 5. Okay, we know that we've got it right smack bang in the middle. We've got our axis of symmetry here. Okay, so I'm going to try and draw that nicely symmetrically. That's not too bad. Okay, and now I can put my information in. So this becomes 1 minus 16. I can now label my axis of symmetry. That's 1, and I can also label my y-intercept here is 15, minus 15. Top it off, label your axes, and that's a pretty decent sketch. Okay, I'd also probably type in, or write in, sorry, the equation, right? But because it's right up here, then I won't do it. But if I was sketching in a test or an assignment, I would actually write it in. Okay, let's look at another one. Okay, so this one that we're going to look at now is clearly it's in vertex form. All right, again, this value here, that is positive. So, and again, just from looking, I can see that it's going to be convex because it's in our vertex form. Okay, ax minus h squared plus k. That means our vertex will be reverse the sign for that value h and keep the sign for k. So I know from here my vertex is going to be 2 minus 3. My y-intercept, as we have done all along, 0. So this now becomes y equals 1/4. Okay, 0 take 2 is minus 2 squared minus 3. You can pop that into your calculator if you want to. Minus 2 squared is 4. 4 times 1/4 is 1. We get minus 2. Okay, so 0 minus 2. Now to find my x-intercept, we make y equals 0. You have a bit of, well, you have a couple of options here. You can expand everything if you really want to. Okay, so you'd expand, get everything on one side, then you can either use the quad formula or whatever. Since it's in this form, I'm going to do something a little bit different. And what you should do, we're going to get rid of this minus 3. That becomes positive 3 on the other side, equals 1/4 x take 2. All squared. Remember, what you're trying to do is solve for x. You're trying to get x by itself. So this times 1/4. I'm going to get rid of that by dividing by 1/4, or in other words, timesing by 4, because when I see this written, I hope we all know that that is the same. Timesing by 1/4 is the same as dividing by 4. Okay, so to get rid of that, I can just times by 4. So now I have 12 equals x minus 2 all squared. All right, we're rocking the algebra now. How do I get rid of the squared? I am going to square root. That leaves me with x take 2, and we have to remember that when we square root, that's a plus or minus there. And to get rid of the take 2, I'm going to add 2. Now, remember with the square root, we should be able to do this quicker than going to our calculator. We check, is there a square number that goes into 12? And yes, there is. It's 4. So it's root 4 times 3, which we can reduce to 2 root 3. That is it simplified. Okay, so those are our x-intercepts. So now we have to pop it all together. If you wanted to, you could check on your calculator what this actually looks like, but you'll see, hopefully, we might not even need that. Drawing my axes, we've got a vertex of 2 minus 3, okay, so I can pop my axis of symmetry in here. Again, it's a sketch, I'm not measuring it out exactly. So x equals 2, and then my vertex is going to be down somewhere, so let's say here is minus 3. My only decision is would the graph sort of go like this and like this, like cut it here, or would it cut it over here? Now, in the olden days, right, just type that in, you can figure that out on your calculator. Obviously, we can look at our graphics calculator, but we also have our y-intercept here, which we know is minus 2. So that tells me that it has to cut down here at minus 2. So, you know, it's going to look something like so. So happy to draw that now, but let's just remind you that you do have a graphics calculator, and let's see how you could do that and help yourself to draw that pretty easily in a test situation. So imagine if you didn't have the graphics calculator, you can just do what we talked about, right? That it would have to be looking like this. Okay, because that is minus 3, and then we know that our y-intercept is minus 2, so we can just label all of this. Okay, so this one would be 2 plus root 2, and this will be 2 take root 2, and everything else is done. But let's just confirm that. So if we had the calculator was permitted, then I would have gone straight to 5. We're going to pop in 1/4, right, x squared underneath your alpha button. Oops, got a bit excited. It wasn't x squared, was it? So use your arrow key. That was going to be x take 2 all squared minus 3. Okay, we'll stick with shift view window and stick with standard. It's already there, so I don't have to press F3. I did anyway. Draw. And now we can compare the pair. It's pretty good. We're expecting it to be reasonably wide. Why? Because of that quarter there. That makes it quite wide. Hopefully getting the hang of being able to sketch these functions and using slightly different techniques depending on how the equation is given to you. Okay, in what form I meant to say there. Okay, last one. So let's have a look at this. So, okay, last one. Here we go. So once again, we can see it is going to be convex. Okay, our y-intercept. All right, keep the habit. It's just going to be great when you're doing other functions later. So make x equal 0. So our y-intercept is 0 minus 4. Now to get your x-intercept, okay, we're solving. As I'm writing this down, I'm sussing, are there two numbers that times together give me minus 4 but add up to be 8? And there's no way, Jose. So I'm not even going to bother doing trying to factorize. I'm either going to go into the quad formula or complete the square. Now, if we back up to the first one we did, so if you go back to the first video, the first part, right, we already did one where we are using the quad formula. So let's try a different technique for this one and let's complete the square. Okay. And because there is no coefficient in front of the x squared, it's just 1, probably easier to do complete the square. All right, so if you remember you're completing the square, we focus on this, and we know that that has to be divide by 2, gives me the plus 4 there, okay? But when I expand x plus 4 squared, right, we know that we get the x squared, we get the 8x, but we also get this plus 16. So I've actually added 16 to this side, so that's okay. I'm going to add 16 to the other side. All right, all is well, all is good. The take 4, still there. And now let's pop the minus 4 over the other side. So we've got 20 equals x plus 4, and we're going to solve this just like we did before. So to get rid of, instead of me writing that squared there, to get rid of the squared, I'm going to square root. And that's a plus or minus. Once again, when we see something under the square root, we check. Is there a square number that goes into 20? I can hear you all yelling. Absolutely. Once again, we've got our favorite friend 4. So root 4 becomes 2 root 5. We've still got the plus or minus there. 2 root 5 equals x plus 4. And now to get rid of the plus 4, we shall, you guessed it, take 4. Okay. What do we need next? We've got the x-intercepts. We've got knowing if it's concave or convex. So the last thing we need is, let's find our vertex. I've got money on that that's going to be our axis of symmetry right there. Right, but if you want, you can confirm. So using our x equals minus b over 2a minus 8 over 2 times 1, which is 2, and lo and behold, it is minus 4. Winner, winner, chicken dinner. To get our vertex, okay, minus 4 something, so we're going to replace x with minus 4. So that becomes minus 4 squared is 16. 8 times minus 4 is take 32. So minus 16, take 4, we get minus 20. And like a cake, let's Bake it all, put it all together. Here we go. So let's put it all together. Just use my calculator to check, right? These values here, -8, so that's why it's veered. My axes are veered. Got a bit more space on the left-hand side, so we're going to go through here and then very small positive here. Okay, so I tend to draw this first. Oh, that's not very good. Maybe I should put my axis symmetry in first. Okay, there we go. Somewhat symmetrical. Now draw in my axis of symmetry using a ruler. Okay, I'm not using a ruler because I'm doing this on the computer. Okay, so this now becomes, this is -4 plus 2√5, and our friend over here is -2 take, oh, -4, sorry, -4 take 2√5. Sorry, that's -4, and then my vertex here is -4 -20. So scale is a little bit dodged there, right? She could have been a little bit higher up, but anyway, I'm happy with that. So there you go, sketching quadratic functions given to you in 4 different forms, and so we can use the quad formula, the vertex formula, completing the square, and of course factorizing. Hope that helps.